Alright, so today we'll look at how the TensorFlow works and what are the most common functionalities and how we can create a model and we can train the model with the help of TensorFlow and Keras. So first of all, the installation part, we have to say pip install TensorFlow, and if we want the GPU version, we can say dash GPU also. And for a particular version, we can do it like this, double equals to, and the version of the particular TensorFlow. Next part. So what we are looking here is loading the data, creating model and saving model. So we'll open this notebook and to take a iris dataset. What this iris dataset is, let me show you. First we'll import all the libraries. So we'll need pandas to load the dataset, TensorFlow for the creation of model. So here is the dataset. So we have sepal length, width, petal length and petal width. So by these features we have to classify the species of the flower. So this is the problem statement and we are going to solve it with the help of TensorFlow. Or we can say neural networks, or another thing we can say is deep learning. So this is what we have. We'll shuffle the data set as it helps in converging faster and more properly, and we'll convert the categorical values to the numerical values. And then we can see here we have three categories. Okay, and then we'll separate the feature with target and we'll quickly skip through. I'm assuming two or three things here. First one is you already know the Python programming. Second is you already know the basics of deep learning. So we are just implementing the theory part of deep learning. So I'll skip this and explain it later, this column, and we'll jump through model creation. First of all, let me run all these cells. Okay, so here we have our model creation part. So we are instantiating a model, which is tensorflow.keras.sequential. Sequential model means we are just creating a simple neural network. So we'll pass the data sequentially. So what does this mean? This is the input layer. Visualize this. Input layer, hidden layer, another hidden layer, and this is the output layer. So in the first hidden layer, we have 32 units. In second, we have 16. In the final one, we have 3. Why 3? Because we have 3 categories to classify from. So that's why we have 3. And the activation function, we are using ReLU here. And in this one also we are using ReLU. And in the final layer, we are using softmax because we want the probabilities. So softmax will output the probability of which class the features belongs to. Okay, so we can see the model summary here. Model summary is stating, okay, now here we have 544 parameters at this layer and 528 at this. In total, we have 1203 parameters. So these are the trainable parameters. We can freeze them, some of them also. We can add dropout layers. So that we'll talk about in a few moments. And then we'll compile the model. For that, we have to say model.compile, and loss we'll pass it like this. Optimizer, we have said Adam, and we are checking our model with the help of accuracy. So there are so many. Suppose we were doing a binary classification. In that case, we would have chosen the activation as which one was that? Sigmoid activation function, and here we would have said binary cross entropy. There is one more way to say to pass the losses here. So as we can see here, we have not this, but we'll say tab, will press tab and it will give us, see, these are the losses we have: binary cross entropy and categorical cross entropy. And for the regression problem, we have mean squared error, mean absolute error, and these all type of losses we have here, and we can pass it like this also. So we would have said pass categorical entropy, so, and pass the loss is equals to this variable. And similarly we can pass the optimizer also in this way. So here we have passed Adam, but otherwise we could have said like this. We have so many optimizer present here: ADA delta, ADA grad, ADAM, and RMS prop. So these are the mm, optimizers that are present, and we can suppose we are tuning these parameters. So we could have set learning rate, so we can see what how we can tune this. So we can pass the learning rate and all other hyper parameters that we can tune. So that's how this functionalities work. Now we have compiled our model, and then we are passing, then we are starting the training. So we will pass the features and the targets here, and if we want, we can also pass the validation data here. So we are passing it here, and then we are saying epochs is equals to 200. So we'll train it for 200 epochs, and these are some callbacks that I'll explain in a moment. So here we can see the loss is 3, and this is decreasing, and validation loss is also decreasing here. Accuracy reaches to 1. Okay, and we can see training stopped at 106th epoch. Why? Because we said here early stopping. Mm, Before explaining this, let me open this part. So where it is, I'll quickly open this and show you the here is this notebooks, and in the YouTube we'll see the part 1. Okay, here we can say in the command line we'll say, see here command is given, where it is, here it is, Tensorboard. So we'll copy this from here and paste it in this one. Okay, so it will load the TensorFlow library, and it will render the graphs relate the performance of our training. So we'll see in a moment, and while this load, I'll explain this early stopping and what is this Tensorboard callback. So what we are here doing is, we are we have to, suppose we want to visualize this, the training part, how the loss is going down or up. So we want to plot this on a graph. So TensorFlow has a built-in functionality to plot this, so which is Tensorboard. So let me show you where we have here Tensorboard callback. That's what we have defined here. We have said TensorFlow Keras callback Tensorboard, and this is a log directory, and histogram frequency is equals to 1. Okay, so which is this log directory? We have said it like this, and here we can see this is logs directory, and here we have some files, and we can check this out whether this have started or not. Okay, this is Tensorboard is running at open localhost 6006. Okay, we'll check here. Okay, our Tensorboard is running. So here we can see, we can check here. Okay, there, because these are some from previous training that I did, this is showing that one also. So we can see the recent one is from 28 December 29 December. Okay, we can see here this is pretty much messed up, but this functionality is pretty much explained. Okay, so now next part is somebody is calling me. Let me. Okay, so next part is early stopping. What is early stopping? Early stopping is, so see here I have passed the loss. Monitor is equals to loss. So what this early stopping is monitoring is loss. And one more thing, patience is equals to 3. That's what I have passed. So as I was explaining, the model stopped at 106 step, but it should have ran to 200. Why not? Because we can see here we were what we were monitoring loss. So we can see whether the loss is decreasing. So loss here, it was 1032, it increased to 62, and then increased to 108. Then here also it is decreased from here, but greater than this one. So I said patience is equals to 3. So for the three next epochs we can track the loss. If it is not decreasing, stop there. So that's what we have. That's how the early stopping is helpful. So we could have tracked this accuracy also, we could have tracked validation loss also, or validation accuracy. That depends what our use case is. And we have also seen how Tensorboard works. So next is accessing the weights. So we can access all the layers of the model like this. So we can say model dot layers. So here we can see, as we can see here also, we have four layers in our model. So these are stored in a list. So we can access it like this. We can access it by indexing. So here we can see this is the first layer. This is the second layer. We can also say, see here, we can check the weights of this layer. We can check the biases of the layer. Biases, or what was the, we can say check the bias, and there are many more things we can check here, like activation function. What was the activation function for this layer? So let's check this. Okay, it was ReLU. So the alpha value was this much, threshold was this much. So these are the kind of functionalities we can track. And for layer in model.layers, so we can also check it like this. Print layer. Okay, so these are the layers, and we could have said before starting the before, let me show you. Here we could have said like this. um, let's cut it from here and paste it here. We could have said layers dot trainable is equals to false. So it would have freeze the weights of the layer. So that's it. That is helpful in when we are doing transfer learning, some kind of transfer learning. We could have added another layers, and then these layer are already freezed, and we could have trained on the added layers. So these are the functionalities. Okay, everything is looking good. Now next thing is, we have talked about this. Now we'll talk about loading the image data, and then we'll talk about the transfer learning part also. Okay, so we have here, okay, so how we can load the image data. So TensorFlow, or we can say Keras, provides a simple functionality, which is image data generator. So we can store image in a folders like we have here. Where is it? You know, so simply we can say, if we have a folder, say data, and in that folder we have two directories, cats and dogs. So see here, I am also doing, I have a this training data directory, which is this training data directory, and this name is named as data, and in that data folder I had cats folder and dogs folder. So cats folder contains all the images of cats, and dogs is dogs. So it automatically, let me run these quickly. Then we'll be able to see what I meant. See, it is loading. Okay, so automatically it said found this much amount of images that belongs to these two classes. And what are these classes? We can access it like this. We are saying training data dot class indices. So we can see cat is equals to 0, dog is this dog value is mapped to 1. And then we can pass this training data directly to our model.fit. And here also we are creating a max pooling layer, creating convolutional layers, and then flattening, and as earlier adding dense layers to it. As I already discussed, we can pass the activation as segment if we are doing a binary classification. So here this use cases of binary classification. So, and next this one we forgot to. We can say model.save. This is a very important part. One day I was training a model. It trained for around 2 hours, and then somehow the this notebook got corrupted, and then I had to retrain the model again. So don't ever do this mistake. Always save the model. So we can save the model like this, or we can say model.save weights only. There are so many methods. We can check on the TensorFlow documentation also. So we can save only weights, we can save the whole model, we can do all kind of things. So we can load the model like this, tensorflow.characters.load model, and simply passing the name of the model that we created here. So that's it. And one more thing that I wanted to show is transfer learning part. So here we can see transfer learning. So TensorFlow have so from TensorFlow Keras applications we have lots of already the architectures we can say, and this ResNet that I am loading here is already pre-trained on ImageNet dataset. So that's why it is very helpful, because it is already trained on millions of images. So that's why I just have to, I will see, I have loaded this model. This is pre-trained. I am passing this input shape, and include top is equals to false. Here what I am saying is leave out the last two or three dense layers, and the whole other, the previous structure, that is convolution layers and all other structure, I'll keep. And then resnet.trainable is equals to false. We could have said it like this also, to freeze the layers, or rather to freeze the whole architecture. I have said it like this: resnet.trainable is equals to false. So it will freeze all the layers in the structure and keep the weights as it is while we are training more of it. So here you can see I am saying model tf.keras.sequential. We are doing it in this way. We are passing the resnet, the pre-trained model here, and then flattening the layer, then adding dense layer to it, and then in the output we have said it, we have put it softmax activation function, and all these processes similar to earlier. So we are training it for 45 epochs. We are passing the training data here. Then we are doing pre-processing and predicting some of it. So that's it. These are the most common functionalities. That's how we can use the TensorFlow for training our deep learning models. So, and there are this tf.hub and this. We have all kind of data set related to audio, related to image classification. These are so helpful if we are just learning or exploring this TensorFlow or deep learning. So make use of it. And this is TensorFlow Hub, which have trained models these are generally helpful when we are doing transfer learning. If we want to do something, if we want to achieve something, and rather than doing everything from scratch, we can take use of these models, these already trained models, these architectures. So that's how easy it is to use the TensorFlow, and that were the most common functionalities.